All right, so this is going to be the last video for class. There's two topics that are in the PDF for today's course that I'm not going to get to just because of the length of the recordings that I've done so far. So this last class is going to be about Leaflet. The topics that I didn't get to, so first is working with shapefiles in R. Just take a look at the example in the PDF if that's something that you're interested in, and we'll sort of cover a little bit about it in this class. And then the other thing is Tigris. So I had a whole section on how to work with Tigris, which makes use of census data. So as we complete the 2020 US Census, there should be updated information available online from the Census Bureau. Tigris makes reaching out and grabbing that information very easy and helps you to pull down some geospatial data using the census output. I'm not going to get to that, but what I am going to do is once we get done talking about Leaflet, I'm going to show you sort of a quick example, very quick example of messing around with Tigris information and then pushing that into Leaflet to get an output, to get a mapping output. All right, so moving on to Leaflet. So when we talked about ggmap, like one of the shortcomings of ggmap was that it requires you to have that Google key. And it used to be that all of these mapping packages didn't require you to have a key, but unfortunately they've added the API requirement on top of it, and so now you have to register your API. Leaflet, fortunately, does not have a key. So Leaflet you can use just by loading the package. And it's a very powerful set of software. It's fairly easy to use. I wouldn't say it's as easy to use as ggmap, but the good thing about Leaflet is that there is a cheat sheet, which you see up here, and that's available inside the cheat sheets folder. And I think it's in week 1, the data science portion. So if you go back and take a look at week 1, you should have access to this cheat sheet. So what is Leaflet? So Leaflet is based on JavaScript, and it creates, using open source maps, sort of interactive map widgets in R. And I would guess that all of you have seen Leaflet type maps before. So anytime you go to, if you go to the New York Times or like the Washington Post, or there's a bunch, I mean, just about everything out there is using some version of open source maps, and a lot of those are riding on top of the Leaflet architecture. And each of these things, so creating one of these things in R is fairly easy. So, and you can see sort of on the cheat sheet here, like exactly how to make a fairly easy map widget, but here's what you're gonna do. So the first step, we wanna create the map widget by calling the Leaflet function. And the Leaflet function does essentially the same thing that the ggmap function in ggmap or the ggplot function in ggplot2 does. It initiates your, initiates your output object. So in this case, the output is going to be a map widget. And so anytime you start a Leaflet plot, you're going to first call the Leaflet function. So I'm just going to create this little map here that I call M and assign it to the Leaflet function, which when I do that, it just gives you, in this case, this little object. I don't actually know what this object is, other than a map widget. I don't know what type of object it is, but actually we could figure it out by doing class on here. Leaflet HTML widget. So similar to ggplot, like it creates your canvas. It just initiates a mapping object in your environment, right? So what you want to do is you want to take that mapping object and you want to add map tiles on top of it. So we're going to take the widget that we created and we're going to use this function add tiles. And by default, this is going to give us the OpenStreetMap tiles. All right. Oh, whoops. We need to put our mapping object in there. All right. So now if I call M, it's just going to give me a little map. All right, and you can see at the bottom, this is Leaflet generated OpenStreetMaps. I don't know what this CC by SA thing means, but anyway, so that takes our canvas and then overlays, in this case, like I said, by default, the OpenStreetMap tiles on top of it. All right. So now we want to add just some little points of interest onto the map itself. So we're just going to add another layer, and that layer is going to use this function add markers. And as you can probably guess, the add markers function is going to just put points of reference onto the map itself. And these points of reference require 2 arguments, the latitude and the longitude. So the ones that I'm going to give it are negative 77.344767, and latitude will be 37.223737. All right, and then I'm going to put actually let's hold off on that for a second. All right, so we've taken the map widget. We put like a background of actual maps onto it, and now we're adding a point of reference. And so we should now, if I zoom into the resulting map by calling M, we should have a point of reference on the map itself. All right. Now, probably the biggest way that Leaflet differs from ggmap is once you make a ggmap output, that output is static. There's nothing that, I mean, you can zoom in, but it's just raster data, and it's going to look ugly once you start zooming into it. The really nice thing about Leaflet is the output that it creates is fully interactive. So if I want to zoom in or zoom out, or I want to pan left or right, I can do that, right? And I can zoom all the way out to like the whatever world level. All right. And this location that I actually put in here, it would be the location that you guys would be sitting right now if we were doing the class live, but it doesn't have a whole lot of meaning to you right now. Okay. Anyway, so that's the fundamentals behind Leaflet. All right. So you've got a bunch of options now that you can use. So the first option, and actually before I jump into that, I want to write a quick section here on typical Leaflet input. So Leaflet doesn't use the plus sign to add additional layers like ggmap and ggplot do. It uses the pipe operator. So typically when you see Leaflet input, it's going to look something like this. So the Leaflet function, and then you'll pipe it into the tiles layer, then pipe again to add whatever markers you want to put on there, points of reference. All right, so when I run that and then call M, it should give me the exact same thing. All right, let's make sure that it does. Oops. So when you use the pipe, you don't have to go back and call M each time. It's just like with dplyr pipe operators, it's assumed. So this object M is going to get stored the entire time. So now when I run it, we actually get the map. Okay. So let's go over some options. So the first one, options on the Leaflet function call. So these are going to be an argument called options, and then we're going to do the function Leaflet options. And this is a capital O. All of these, or most of the Leaflet functions and arguments are camel case. So like subsequent words get capitalized. So we do min zoom equals 4, max zoom, and I believe the zoom levels are the exact same as what we had in ggmap. So like 1 would be the world and 20 would be down at the building level. But we'll put max zoom equals 15. And then let's run that. And so you're not going to be able to tell the difference really from this one compared to the last one. However, this one is going to restrict my zoom a little bit. So as I go out, the max that I can go is level 4. And then as I go in, the closest that I can go is down to level 15. And I guess you would set that, this right here is the closest that I can get in. The reason you would set that is so you're not pinging the server just nonstop if you were to send this out as part of an application or something like that. The other thing that you could do is you can set the initial view. So I'm gonna copy this over. We're going to use the function set view. And all it takes is a longitude, latitude. So the marker that we have is on -77 longitude. The view that we're going to create is on -122 and then a different latitude as well. And we'll put zoom level 10. So all that's going to do is when I initiate the map itself, the initial setting is going to be something different. So most of the time you probably want this to be set so you can actually see your points of reference. But in this case, I've set it on top of Seattle. And so our point of reference is going to be like way over here, over on the eastern side of the United States, which wouldn't be tremendously helpful. But like I said, if there's a like point of view that you want a decision maker or a user to see when they first open the map, then this is how you set that option. All right. You've also got, so this is what I was going to show you before, the pop-up and labels that you can add on here. And this is to the add marker layer. So if I were to do pop-up, and then I can just put a string in here. So students located here. And then run that. When I click on, and I don't want to do the set view. And so now when I click on my reference, then it gives me a little pop-up that says students located here. I've also got labels, and the difference between a label and a pop-up is a label will show up when you hover, a pop-up will show up when you click on the item. So if we did label, and then I'm just going to say this is the hover content. Then run that. So now if I click on it, it gives me students located here, close that out. If I hover on it, it tells me this is the hover content. All right, so there's a bunch of different things that you can do. You can, and I mean, the big thing is also you can change this icon. You can use circles, you can use little rectangles, you can, so I've designed my own icons to look like operational graphics for a course that we do in Orson Mac. So I've got little, like, the enemies are red diamonds, and they've got X's in them for infantry units. And so when we plot our targets, it goes out and grabs that image, and then it uses that as the plot on the map, and it looks pretty good. And like I said, like the really nice thing about it is, any other overlay that you create, if it's not done with, sort of your mapping software, then it's just stagnant. And in our case, we can pan around, show the decision maker different things. If you use it in a brief and they say, hey, I want you to focus on this area, we can just immediately scroll right into that area, and we can see exactly what the operation looks like there. All right. There is a section specifically devoted to messing around with shapefiles in the PDF for today, so I'd ask you to look at that. And these are shapefiles with Leaflet. And basically, you're going to make use of the RGDAL package. I'm not sure how that's pronounced, but that'll pretty easily take a shapefile document, read it into a format that Leaflet can use, and then plot it onto your overlay. All right, but what I want to do is I want to mess around with Tigris. So like I said, Tigris is a package that makes use of census data. And so make sure you've got let me create a new section here. Make sure you've got the Tigris package loaded and installed in your session of R. I've already got mine up and running. But this is what Tigris will allow you to do. So if I create, let's call this thing states poly, and I'm going to use this function that's found inside the Tigris package called states. And what states it does is it goes out and it grabs state boundaries for me. and in this case, stores them in this object called states poly. And we can see what that object actually is by running a quick class on it. So that's a spatial polygons data frame. And if you click on it and go through all of the information kept here, so we've got different regions for region of the country, the like state number, basically state codes for the United States Postal Service. So like, you know, West Virginia shows up as WV. The area of that state that is made up of land, the area that's made up of water, like there's a bunch of information out here on each state. But the really nice thing is that it gives us this sort of plottable border layer that we can start messing around with. All right. And to do that, it's really easy to get Leaflet to plot that for us. So what we're going to do is we'll just initiate the map with the Leaflet function and then add tiles, and we're going to do the default tiles again. And then I want to do this function add polygons, and for the data argument, I'm going to tell it, hey, give me the states poly data. All right, and so when I run that, it's going to take a while because there's a lot of information here. Remember I said mapping software is oftentimes slow in R. But when I run that, it's going to give me, let's zoom in on it to see this whole thing, the United States with each of the states' borders outlined. All right, which you may not be super impressed by, and you know, in fact, like probably won't use like this in particular, but you can also, so in addition to the states function, you've also got a function for counties, you've got a function for zip codes, or they actually use the zectas, the zip code, I don't know what they actually are, something, but anyway, you've got a function for that, so you can go out and grab that information. And then, you know, obviously, like you don't want to just put a state border on there. You actually want the states to show up sort of differently when you plot them in Leaflet. So in order to get like a fill on these states, let's go through a quick example of maybe how you would do that. And this, so in our case, the fill would maybe represent, I know we have region up here, so maybe region of the country. So if I take a look at first the region information, so we'll go states poly, and then data $, region. So it tells us we've got for our 54 states or whatever show up in here. We've got values. It looks like 1 through 9, but 9 only shows up twice, 3 times. All right, so it just, all this does is like define regions of the country. So like the Northwest or the Northeast would have a different regional designation than the states in the West, for example. All right, so what we want to do is we want to change the fill for each of the states that we plotted according to the region. And so the first thing that I'm going to do is just create a function called pal that maps colors to different regions. So the way that I would do that, there's this function called color numeric, and you've also got color character, I believe, and color factor if you want to map character or factor type variables to a palette as well. So I'm going to use color numeric, and that expects all of my data will come in as numeric type data. The palette that I'm going to use, and again, this is coming from the R color brewer package, is this color accent. And then we need to give it a domain just so it can map all the colors together. So like basically set up the left and right limits for the mapping. And so the way that I'm going to do that is just take my regional data and convert it to numbers, and then give that regional data to R as the domain. All right. So it'll know, okay, this is how many colors out of the accent palette I need to use to map all of this information. So we're going to go states, poly, add data. I think this is a GeoJSON format. Maybe wrong in that. And then region is what we want to give it. 2 parentheses to close it out. All right, so we've got our function PAL that was created. And all that expects is a set of numeric data that it can map each of the colors in accent to. All right, so we're actually ready to plot at this point. So we're going to go leaflet and then add tiles just like we used to. Oops, don't want to run that yet. Hold on. Stop. All right. So the next layer is going to be the polygon layer. So we'll add polygons. Data, same stuff that we used before. So the states poly. And then we're going to go, okay, fill color. And that's a capital C. And set that equal to, and now we're going to make use of that function PAL. So PAL, and then we got to convert this to numeric again. States poly at data $region. And then we can mess around with some of the additional arguments that add polygons function can take. So we can define the color of the borders with the argument color, and then if you want to make your the fill color more opaque or more transparent, we can set this argument fill opacity, and so that's a 0 to 1. So we'll make it 0.8 to make it a little bit darker so we can see it better. And then weight. So this is the stroke weight of the border lines themselves. So a stroke is like the thickness of the line. So if I said 1, that would be a rather thick line. Let's do like 0.4 so we can see the line, but it's not super thick. All right, and that's all the arguments I'm going to give this. So let's go ahead and run this, and then what we should see is the states showing up as different colors based on the region of the country that they're assigned to under the census data standards. And so I zoom on this and scroll in, and we've got Northeast showing up in green, the Southeast showing up in this like salmon color, Midwest in purple, and then the West shows up in yellow. And then we've also got, so like Puerto Rico gets its own designation, and then the territories out in the Pacific. So Hawaii obviously gets a color, but if I find American Samoa, which would help if I actually knew where it was, maybe this is it. Yeah, it looks like it. So American Samoa gets their own designation out there. All right. And so that's a quick, dirty introduction to Leaflet. So what I want you guys to do is we'll just do a little exercise messing around with some of the Leaflet functionality. So what I want you to do is there's a data set in today's folder called, it's terrorist attacks, but it's called GTD_14 to 17, etc. I want you to use that data set to create just a quick leaflet plot of terrorist attacks. And I would encourage you, while you're doing so, reference back to the leaflet cheat sheet. If you don't want to add just the standard tiles, come down here and you can use the function add provider tiles, and you can get something that looks slightly different. But sort of mess around with different markers and pop-ups and label options, and just have fun with it and create something that you think would be useful. All right. Also keep in mind, so this is the last time that I will meet with you guys. The next 2 lessons you're going to have with Dr. Marlin, and you'll go over some machine learning stuff. And then on Monday, you'll do a joint class with the beginners where you'll talk about Shiny. And Leaflet, because it's interactive and because Shiny is also interactive, the two work very well together. And there's a whole section here on the cheat sheet for how to mess around with Leaflet objects inside Shiny. So Monday when you get done with class, or Justin may have some stuff in there about
Leaflet as well. Keep in mind, you can create some really nice mapping objects using Leaflet and Shiny together. All right. Okay, thank you.